Hi guys, here for our last installment on enzymes. So let me get this shared. Okay. So our last installment we're talking about for enzymes, and here we're talking about regulating chemical reactions. So obviously we figured out how we can take these reactions that would happen spontaneously and speed up the process using enzymes. But we want to be able to control what reactions happen when based on what the needs of the cell are. So just because we made it easier to do the reactions doesn't mean we always want to be doing those reactions. And so we have to have a way to regulate this process. So how would we do this? First of all, we can control where and when the enzymes are active. So we make them work where we want them to work and when we want them to work, and not just any old time. We can actually switch genes that code for enzymes to be turned on and off. So we can control it genetically on when they're turned on and when they're turned off. So we're going to look at allosteric regulation. Remember, we had that allosteric site on the enzyme, and it could change the shape and block the process. Okay. So you notice we have two different enzymes here. One has a single site, one is a multi-subunit enzyme. And so the allosteric site is going to be in a slightly different location. But allosteric enzymes typically have two binding sites. They have the active site and the allosteric site. Okay. And the allosteric site is considered a regulatory site. It's anything other than the active site where the reaction with the substrate happens. Okay. So allosteric regulation, the molecules are going to bind. So these are non-covalent interactions. Remember, so they are reversible. We try to avoid those covalent interactions. Those are typically caused by poisons, toxins, things that are not naturally occurring in our bodies. So the molecules are going to bind to the allosteric site, which changes the shape and therefore the function of the active site. It may result in inhibition, obviously by an inhibitor, or stimulation by an activator of the enzyme's activity. So the allosteric site actually can slow down, or it can stimulate, speed up the reaction. So here's an example of allosteric regulation as an activator. So an allosteric activator is going to be a substrate that binds to allosteric sites. So you'll notice this is one of our multi-enzyme forms, and you notice here's our little allosteric sites activator, and it's going to bind right there to our allosteric site. And it stabilizes the shape of the enzyme so that the active sites remain open. So you'll notice in our inactive form, everyone's closed and the substrate could never get into the active site. But when we add this little allosteric activator, it causes the shape to change so that all of those spots are open, and the active site then can receive the substrate and perform the reaction over and over. So we can actually have an enzyme that's normally turned off until an activator hits its allosteric site and turns it on. An allosteric inhibitor basically is going to do the opposite. So you'll notice in the active form, all of the sites are open. The substrate is going to bind to the allosteric site. So here's our substrate to the allosteric site, and it stabilizes the enzyme shape. So it causes a shift in the shape so that the active sites have all closed, and this would be an inactive form. So we can either activate using the allosteric site, or we can inhibit with the allosteric site. And then we have a process called cooperativity. So notice in the inactive form here, everything's closed up, but in cooperativity, the substrate is going to bind to one active site and this is on an enzyme with more than one. This one you'll notice has 4, which actually stabilizes it to the active form. So we're putting this specific substrate in one of the active sites. Now the other active sites are open for the substrate reactions that the enzyme is designed to perform. This is considered allosteric regulation since binding at one site changes the shapes of the other sites. So even though we're not actually binding at the allosteric site, because one is controlling what all the other sites are doing, we're still classifying this cooperativity concept as an allosteric regulation. Okay, and this brings us to the idea of feedback inhibition. Sometimes the end product of the metabolic pathway can actually act as the inhibitor to an early enzyme in the same pathway. So here we have enzyme 1. And it leads to an intermediate, which leads with another enzyme leads to the product. Well, if you've made all of the product that you need, there's no reason to keep doing this reaction and make more product when you don't need it. So what we have found is that we have some of these systems where the product then can go and it can connect to the enzyme and bind into the allosteric site to basically inhibit the reaction. It changed the shape, so now that original substrate can't fit. When the amount of product gets too low, that site can then be released and we can continue with the process. But for now, because we had so much product that while the pathway continues, the substrate, we may still have substrate, but we don't need it. When we run out, when we start using all the product up, then that piece that was blocking it goes away and we restart the process. Okay. Okay, so now we have a couple of practice free response questions. The first, the common cold is a viral infection that affects the upper respiratory system, upper respiratory tract. Symptoms include a cough, runny nose, and a fever. So A wants you to identify what, as you can tell, I'm progressing along and we're now at the end of first period. Okay, so A wants you to identify what happens to the body when it has a fever. And then B, explain why having a fever is beneficial in fighting off the virus. C, explain why having a long-term fever, 3+ days, can be dangerous to the human body. So think about what we've been talking about with enzymes, what enzymes are and how enzymes work. And apply the idea of enzymes and enzymes' roles and how they work to this question. So if you'll pause the video and do your practice free response at this time. Okay, our second free response. The human body needs vitamins to function properly. For example, a deficiency in vitamin B12 leads to muscle weakness and fatigue because the body is unable to produce red blood cells. Explain how vitamins function in the body and why they are necessary. So think back to when we talked about those organic molecules and specifically the vitamins and their role in relation to enzymes, because remember our focus is enzymes. So think about the relationship of the vitamins to the enzymes to answer this question. Pause it while you finish the question. Okay, great. So I'm going to stop sharing, and that ends our notes on enzymes. We'll be moving on to photosynthesis after we finish all our activities with enzymes. Bye.